Okay, so thank you all for being here. Welcome back to the, in a way, sort of first official PCF seminar series, at least our fully online series. So we're very pleased to be joined today by Veli Vermajolki. Veli is a philosopher of science and futures at the University of Turku and a senior researcher in the Finland Future Research Center. He has interest in a variety of topics, including causal and counterfactual thinking, the future of science, the utility of philosophy of science, the interplay between history and future studies, and much more. And we're very happy to have him here today. Veli, I'll hand it over to you.
Yes, thank you. And I'm very happy to be here. And as I already said when we discussed a minute ago, that I'm very happy that this research cluster of philosophy of contemporary and future science is in place, at least for now, because I find it a very valuable cluster and valuable topic. But now I shall share my screen and go to my talk. And you should be now able to see it.
Looks good, we can see.
All right, my title today is Mapping Possibilities, Philosophy of Science and Scenarios of the Future. And here is the plan what I will discuss today. First, I will discuss the difference between predicting future or futures of science versus creating scenarios of that future, and why this later is different and interesting. Secondly, I will discuss or give a sketch of how philosophical theories enable scenario work. So how we can create scenarios by using philosophy of science. And then I discuss how the scenarios that are built in terms of philosophical theories can be assessed. And I will also discuss how this enables new perspectives on philosophical theories themselves. So it's not just that we use philosophy of science to say something about the future, but we use what they say about the future to evaluate the theories. And finally, I will discuss two applications where scenarios that are used in philosophy of science. These are based on my own works, and the point is to just show that scenarios can be useful even in mainstream philosophy of science. One of the applications is a topic that I have discussed in a publication, and the other one is a paper that is under review right now. So let's go into the discussion. First, some background of all of this, and my starting point is that philosophy of science has increased our understanding of science. I think this is not controversial, at least to some extent. What is problematic, however, is that quite little has been said about possible futures of science in terms of this understanding. And this is surprising for two reasons. One is very practical. Changes in science are to be expected. Science has changed in the history, and so it is expected to be changed in the future. And science has an enormous role in our lives, and the changes in science will change other aspects of our lives as well. So there really should be effort to use all understanding we have about science to discuss these futures in order for us to be prepared and able to react to them. So this is a kind of practical issue that should be pointed out. But on a more theoretical note, it seems difficult to see how we could understand how some domain like science has developed and yet fail to understand how it could develop in the future. So if philosophy of science or science studies in general has increased our understanding of science and the development of science, there should be tools to discuss the future of science. So there is this theoretical idea behind this. But there are several issues that have made philosophers quite shy about discussing the future of science, and I think there is an interesting point made by Popper, which is kind of forceful point. In the book Poverty of Historism, Popper writes that the course of human history is strongly influenced by the growth of human knowledge. This is, I think, this is not controversial. But Popper continues, however, we cannot predict by rational or scientific methods the future growth of our scientific knowledge. This is something that Popper just states, and therefore we cannot predict the future course of human history. So from the idea that we cannot predict the growth of scientific knowledge or changes in it, we cannot predict the future course of human history. And what I argue today basically is that this idea of predictions and predicting the future of science and the future of human history is somewhat misplaced, and too much focus on our ability to predict or inability to predict as blind us about certain important issues. And I just suggest that there has been too much focus on predicting discoveries and innovations, which are individual events, basically. When we try to predict some discovery or innovation, we are trying to predict individual events. And this is always difficult. Predicting any event is difficult. And it is even more difficult in the case of scientific discoveries and innovations. There are several ways one can put this point, but one is that the impossibility stems from the fact we should predict changes in our cognitive horizons on the basis of our current cognitive horizons. And if we expect or knowledge and assumptions, in other words, our cognitive horizon to change in the future, then how can we kind of trust in that cognitive horizon? How can we use it to predict the future? The other problem is that how can our current cognitive horizon have the conceptual tools to discuss concepts that are not existent yet? So it is almost impossible to predict future discoveries and innovations and give detailed pictures of what will happen. But my argument is that despite this, the future in general might be on our grasps. And this is based on the idea that we are able to produce scenarios of the future, and we are able to produce scenarios of the future of science. Here, what is meant by scenario is a description of a future situation and the course of events which allows one to move forward from the actual to the future situation. The important part is that it is a kind of description of a possible state that might occur in the future. That is what is meant by scenario. There are several technical definitions of scenarios in the futures research literature, but we don't have to go into that now. This is the basic idea that is sufficient for us today. Now I want to briefly mention this field where I'm, in a sense, currently working in, and it is called futures research, or perhaps more commonly futures studies. But this field is basically the study of possible, probable, and desirable futures. So we want to know what is possible, we want to understand what is probable, and we want to understand what kind of futures could be ethically sound and valuable, which is described by these desirable futures. And an essential component in the mapping of futures, whether we are mapping possible, probable, or desirable futures, is the critical study of our own conceptions that ground different scenarios of the future. So we want to be critical on the ideas that we use to think about the future. And the interplay between understanding possible futures and the critical study of our conceptions, which are the two components of futures research, is crystallized in this concept of alternative futures, which has been a guiding concept in the future research. Alternative future describes a future that is somehow against what we commonly or more automatically think about the future. In general, future research is based on the idea that rather than approximating a likely future outcome, the attempt is to increase awareness of possible futures and thus allow us to prepare for a variety of outcomes. And the main goals of future research are enhancing understanding of the causal processes, connections, and logical sequences underlying events. So when we discuss the future, we want to discuss basically the kind of processes that have existed, exist now, and could exist in the future. So we are not only getting knowledge about the future, but we are able to also reflect on the past and on the current situation. And interestingly, the other goal is to challenge conventional thinking, to reframe perceptions and change the mindsets of those within organizations. The idea is to kind of challenge the ideas that we based our visions of the future on. And finally, this is very often connected to very practical issues, and therefore one of the goals has been improving decision-making to inform strategy development. So when we understand different possibilities, we are able to make better decisions or strategy development, or at least that is how the argument goes. Of course, there is a critical discussion in futures research whether the field has in fact been able to do that, but we don't go into that now. And so the basic idea is that we want to understand possible futures, make scenarios of the future, and therefore increase our understanding and ability to react. But now we go to the issue: how can we make scenarios of the future of science? Even if we know that scenarios would be valuable, that doesn't help us much if there is no way of creating scenarios of the future of science, or if there is not a systematic way that we can somehow justify. And here is the basic idea that I have, and which is based on the idea that we are able to use philosophical theories of science in order to create the scenarios of the future of science. And the starting point is to imagine that we did not have any ideas or assumptions about how science works and develops. If this was the case, of course, we couldn't say anything about the future of that field. And my suggestion is that the best strategy is to use systematic, clear, and warranted accounts concerning the development of science or the nature of science in general. I am not limiting my discussion on this grand theories of science that discuss kind of macro development of science, but other theories can be useful as well. So we go look at where the best theories of science are. And one place where one should look for such account is the philosophy of science. That is my argument as a philosopher of science, because philosophy of science has improved our understanding of science. And now one might ask, but which account should we use? Which philosophical theory? I come back to this issue later, and I will argue that it is actually a virtue that we have many different and mutually consistent theories of science. That is actually a virtue when it comes to scenario work, but I discuss this later. And here is this is a bit abstract. I will give you soon examples and so on to make this more concrete. So I hope you can follow still. But I have suggested in a paper, in a recent paper, that we can use structural taxonomies to create scenarios of the future of science. And I just suggest that philosophical theories can be used to do this. We can find possible structures of the future of science from those theories. And I have adapted the term structures from Staley, 2002, who underlines the boundaries within which events occur and the context that produce events. So structure is something that both gives boundaries and limits what can happen, but it also tells how things can happen. And a natural inspiration for the use of the term structure of future of science is in the philosophy of Thomas Kuhn, and especially in the work of The Structure of Scientific Revolutions. This is the second edition. Of course, the original was published in 1960s. But Kuhn's work describes the basic epistemic, social, and institutional factors that shape the overall development of science. So this is something that the structure in this future sense is trying to capture. This kind of structure in a Kuhnian sense. So by the notion of a structure of the future of science, I refer to possible configuration of factors that produce and set boundaries for scientific development. And we could here think that the structure is like a machine that processes whatever specific states of affairs, conditions, and events are fed into it in a uniform way, following its internal workings. So the structure is kind of the abstract scheme where we start inputting specific ideas about future, and the structure will tell how those futures could evolve and how those futures should be interpreted and so on. So the structure is very abstract item and doesn't in itself give scenarios. But these structures serve as the basis for more detailed pictures, which are scenarios, concerning the future that we create by adding contents to the structures. And by the notion of content, I mean the possible knowledge, methods, and institutional arrangements, and so on, that might be adapted in the future in science. So we have this structure which tells basically how science works and how it could work, and then we put different items in there, and then the structure will interpret to us what will happen given that item. And once we have added some possible content to a structure, we have formulated a scenario of the future of science. And then within a scenario, it is possible to describe particular events if someone wants to do that. Here is a figure that represents this idea that there is this structure, and then we search for evidence for different kinds of things that could take place in science, whether we discovered that or built that instrument and so on. And then we insert these findings to the structure, and that gives us contents. I will give you an example, and I will follow Kuhn because this is a well-known theory and it is easier to follow. I am not suggesting that Kuhn is right about how science works. In Kuhn's philosophy of science, there are mainly two kinds of periods in the development of science: normal science and revolutionary science. And we can say that Kuhn's account defines a possible structure of the future of science. If, and of course this is a big if Kuhn is right, whatever the details, science will be dominated by a paradigm, and this domination will end during a revolution. So there are paradigm-dominated sciences and revolutions and new paradigms and so on. This is kind of the structure. Whatever happens, it happens in this structure and having this structure. And given this structure, we need to fill in the contents in order to create scenarios. For example, we can make different suggestions about which paradigms will continue their dominance. We can suggest which paradigms are under serious doubt and where there could be a revolution. And what are the possible causes of action, given that the field of research is facing a crisis. So this kind of questions we ask in order to put content in that structure. And I will give you an example. This is from my paper 2023, which is a reconstruction of ideas about the future circular collider, the FCC. And here I have reconstructed a kind of debate between Sabine Hossenfelder and Michaela Massimi, who have different ideas on whether we should build this expensive instrument. And here we have the Kuhnian structure, which can be kind of squeezed into the idea that either there is paradigm dominance or there will be a revolution. And here we make two assumptions in order to create two kinds of contents. We can either assume simply that the FCC is built, and the other assumption is that the FCC is not built. Here we are inserting content into the structure. And then we can create further content. We can discuss futures where the FCC is unable to solve problems. This structure suggests that this would lead to a revolution. Or there could be an ability to solve problems, and we could make expected discoveries, in which case the paradigm that the Large Hadron Collider has set would continue. Or there could be a situation where experimental results force a revolution, that we have some results that contradict the current theoretical understanding. And in this way, we can create scenarios of the future. We can discuss different things that could happen. We use the structure to interpret the contents, and therefore these structures enable us to think further in the future. But that is briefly the idea with an example. But the interesting question, of course, is even if we are able to build these kind of taxonomies, where we have scenarios based on a structure taken from a philosophical theory, there is still the question of how to assess how good these taxonomies are and how good the scenarios are. Of course, one could have all sorts of crazy theories about science and use them as the basis of the taxonomies, and then we would have poor scenarios. In other way, we should somehow be able to keep the speculation in control and assess the taxonomies. Here are some suggestions that are helpful when we assess taxonomies. The first two are straightforward to something that already exists in philosophy of science and is always used when or commonly used when philosophical theories of science are assessed. This is independent of whether we are going to use them with respect to future and so on. First, we can use historical considerations, and we can use the history of science as evidence for theories in one way or another. And of course, this is a difficult and a problem-ridden issue that has been discussed at least from the 80s, since Laudan and Donovan published their Scrutinizing Science. But the recent paper by Polinska and Martin is a good summary of the problems involved. But I would just say that no matter how difficult it is to use history of science as evidence in philosophy of science, the estimating of possible futures of science is under epistemic control to the same extent that historically oriented philosophy of science is because both use these historical considerations as evidence. So there is not a specific problem. And it seems that we are able to use them, at least to some extent, as evidence. And then there are, of course, philosophical virtues that a theory can have. The theory that is in the base of the taxonomy. It can be a coherent theory, it can be simple, and it can be explanatory theory. And things like that. Very well-known philosophical virtues that we use when we assess philosophical theories of science. But now I move into more specific ideas that are interesting in relation to the future of science. First is that we can assess the usefulness of a taxonomy. First, we can simply discuss how rich the scenarios are that it gives. How many scenarios, how different those scenarios are, how far they go, and so on. This is a virtue of a taxonomy. Of course, if a taxonomy is too large, then it becomes a practical problem that we cannot use it and fill it anymore. But basically, the richness of scenarios is prima facie is a virtue of a taxonomy. And for example, in this case, even this very simplified picture of Kuhnian structure gives us quite rich scenarios. And then we can also look at the taxonomies and see whether they have what I call faulty scenarios. And these are scenarios that are dubious, incoherent, or ambiguous. And taxonomies should avoid this kind of fault spots, as I call them, these faulty scenarios. And I will soon discuss how this can be helpful in seeing philosophical theories in new light. Because if we understand that the philosophical theory creates a scenario that we cannot comprehend or understand that is incoherent, then we can perhaps say that there might be something missing or some ambiguity or incoherence in the theory itself. And here is an example. Let's consider that the future circular collider is not built because the current projects with Large Hadron Collider are not deemed fruitful enough. And one could ask if this is a revolution given the Kuhnian structure. So we are in the content 2 here. And there is this error with question mark because it is difficult to say or interpret in Kuhnian theory whether this will be a revolution, because on the other hand, this would take away a largely successful and accepted way of doing physics. And there should be something in place instead of that. But on the other hand, there are no crises or anomalies in this kind of very forcing sense that Kuhn often discusses that are required for a revolution. So there are some reasons to think that this is a revolution, and some issues that suggest that it might not be a revolution in Kuhnian. And of course, this suggests that the revolution is somehow ambiguous concept in Kuhnian philosophy of science, and this is actually something that has been suggested as early as in 1970s, where Tolmin pointed out that the absolute revolution versus normal science distinction is too restrictive interpretive tool, and future-oriented considerations confirm this. And in this way, the future-oriented scenarios can suggest that we should somehow clarify in this case, the Kuhnian ideas about science. The second dimension that we can use to assess the taxonomy is that we can build different taxonomies based on different theories and compare these two taxonomies with each other. And we can do this comparison in order to find disagreements, agreements, faulty scenarios and blind spots in the taxonomies. So we can use different taxonomies to see which features are such that they are commonly accepted as possible, which features are unique to certain taxonomies, and so on. And we can perhaps in this way discuss whether some taxonomy is a bit weird from the perspective of other taxonomies and so on. But the idea of blind spots is the most central one from this group, and a blind spot is a scenario that is altogether missing from a taxonomy. So we might have one taxonomy that just says that this something is possible, and there might be another taxonomy that is completely silent about this issue altogether, and we can say that there is a blind spot in this later taxonomy. And for example, we could create a scientific realist based taxonomy and compare it with the Kuhnian one, and we could say that the realism taxonomy is probably allowing more continuity in science than the Kuhnian taxonomy. I actually come back to this soon. And one could say that the Kuhnian taxonomy is perhaps blind to continuity scenarios. On the other hand, one could say that the realism taxonomy is actually blind to these revolutionary aspects of science and so on. So by using these different taxonomies together and by comparing them, we can see what are the possible things that the taxonomies miss and are unable to discuss, and where the future-oriented insights end. And here are some suggestions how we could use scenarios to evaluate philosophy of science. And the idea is that the comparison between taxonomies provides feedback for the philosophical theories. First, given that we can find similarities and differences between the scenarios of different taxonomies, we are able to see how similar or different the theories are. I will soon discuss the issue of scientific realism versus anti-realism in this slide, very briefly. But still, we can use the scenarios to kind of map possible future and use this as a proxy for what in fact are the differences in the theories. In some sense, this might resemble this very old idea of logical empiricism that if two theories make the same predictions about the world, then there is no meaningful difference between them. I wouldn't go that far enough to say that if two philosophical theories produce the same scenarios of the future, they are the same theory, but I would still say that it would be very curious, at least. So I think there should be this idea that the more fundamentally different we think that two theories about science are, the more different their scenarios are. And if this is not the case, then we should perhaps attempt to see the underlying logic of the theories in a more nuanced light. And moreover, the structural taxonomies can indicate that some topic is not analyzed enough in the philosophy of science in general. This is a very practical point, that if we have some like surprising future-related question, and we cannot answer it by creating scenarios in terms of philosophical theories, then it might be that something is missing from the philosophy of science. So if there are questions that seem the kind of questions that philosophers should be able to answer about the future, and we are not able to answer them, then there is this very practical point that there might be some gap in philosophy of science in this case. So these are two ways in which there are feedback loops from future scenarios to the evaluation of philosophical theories of science. In order not to just remain on the level where I claim that we can build scenarios of the future of science and then evaluate philosophical theories in the light of those scenarios, I will discuss now two applications where I have in fact done this, and where this is kind of in line with the literature that we already have in philosophy of science. And this is the kind of ideas that I think are most interesting, perhaps, for philosophers of science. This idea that thinking about the future, even if one does not care one bit about the future, or if one doesn't care one bit about thinking about the future, but as long as this person is interested in philosophy of science, this thinking about future can be a highly valuable tool for the person. And the first application is this. There is the long-standing debate between scientific realism and anti-realism, and this debate seems to have reached a stalemate. Arguments from both sides are supported by different kind of considerations. They are very sophisticated, and it seems that there is no clear resolution for how to or which theory to kind of accept or believe in or consider as philosophically better or more justified. And this statement idea is quite common in the current literature on the topic. And historical evidence, we can point out, can be interpreted to support both positions. And realism and anti-realism appear to form a spectrum of related views rather than fully oppose each other. So people are starting to think that these positions are not two positions that are from some distance from each other, but there are different forms of realism and different forms of anti-realism, and they can be more or less close to each other. And this has led to a so-called distinguishability problem, which says that despite making fundamentally different claims about science, realism and anti-realism do not seem to differ concretely in their implications. The positions appear indistinguishable. So only it seems that they say different things, but when it comes to issues that are more concrete, or when we are asking about evidence and so on, then it seems that there perhaps isn't that much difference in the theories. And this is kind of a peculiar position to be in. But my argument is that scenario analysis can actually enable us to distinguish between these positions. And we can remember that scenario analysis involves mapping out possible futures and analyzing them in terms of probability, possibility, desirability, and trackability. The trackability means simply that when we have a scenario that is trackable, then we can follow the logic of that scenario further in the future. And when applied to realism versus anti-realism debate, this reveals systematic differences between realism and anti-realism, with realism implying more continuity in science and anti-realism more openness to discontinuity. I will not discuss this in detail because this takes a lot of space and time. I hope you just take my word for it for now. And focusing on differences regarding the future and how we can think about it provides a way forward from the seeming stalemate by showing that realism and anti-realism have different implications for conceptualizing possible futures of science. And as said, in general, and this is in general, realism is more able to track scenarios because it specifies which aspects of theories generally survive theory changes. So different forms of realism, like structural realism, say which aspects of theories generally survive theory changes. Of course, realists are not saying that everything in a theory is always preserved after theory change. They say that certain aspects of theory, and for example, structural realists say that the mathematical and structure of a theory is the thing that survives. And this gives us trackability no matter how much science changes, as long as it remains successful, the mathematical structure of our current theories will continue in the future. And we are able to track the future in terms of that structure. And this is in contrast to even the most sophisticated anti-realistic positions, such as the one from Stanford, who in recent writings admits that there are continuities in science, and that anti-realists, according to Stanford, can allow continuities as long as they don't give some general categorization of which aspect of scientific theories survive theory changes. So the idea is basically that sometimes it is the structure, sometimes it is the entities, and so on. And this does not allow as much trackability as the realistic idea about the future. Of course, we cannot tell which is a better position on the basis of what they say about the future, because we don't know the future. My argument is that we can distinguish between these positions, and we can find things in which they disagree, even if we cannot use this straightforwardly as an evidence for or against one of the theories, but they say different things. The other application is oh, there is a weird letter there. But the second application is the debate on pursuit-worthiness of science. And the idea is that of this problem is that science requires resources. This limits the number of research programs that can be initiated and kept alive. And due to this, we have to make decisions concerning which research programs to pursue. This generates a problem of pursuit-worthiness. We have to identify those research programs that are worthy of pursuit. On what criteria can the identification be based? And the problem is tricky because it might not be a good idea to use the actual success of a theory to say that it will be worthy of pursuit in the future, because we probably want to also develop new theories, alternative theories, and so on. And given that these new theories, because they are new, they cannot have actual success, then we cannot say that they are worthy of pursuit because they have been successful. So we have to have some other criteria which tells us when some theory is worthy of pursuit. And I have argued in a paper that this is a problem centered around the question, what could happen in the future? And there are two different questions that are related to future in this debate. We can ask the future-oriented question of what could happen to the research program R in future. We can ask whether this some program is such that it will give us success in the future. This is something we are asking when we are asking whether it is worthy of pursuit. The second question is more general, and it is about what could be the place of R in the changing context of science. And here we have to discuss possible changes in the science and discuss whether R could be valuable given those changes in science. And both of these questions are future-oriented, and they require that we create scenarios of the future of science. And we have to notice that criteria of pursuit-worthiness are built to prepare us for and be able to react to specific types of futures and not others. So certain criteria of pursuit-worthiness enable us to prepare for one kind of future. The other criteria enable us to prepare for different kinds of futures and so That's why the merits of criteria can be assessed against rich sets of scenarios of the future that show first what kinds of futures a particular criterion enables us to prepare for and react to, and what kinds of futures the criterion is silent about. Let me give you an example. Says Eli and Strasser in their 2014 paper rely in their approach to perseverance on the notion of scientific crisis, and this is a quite common idea in this literature that perseverance is somehow related to the idea that there could be crisis in science. And they argue that the need for plurality in pursuits stems from the fact that these times of crisis we do not want to face empty-handed. So we want to have alternative theories and different theories in order to survive the possible situations where our best theories face a crisis. And one could say that this is intuitively nice idea, and I actually agree with this idea. But to take some critical distance, we could ask, all right, let's assume that we build a criterion of perseverance in such a way that it enables us to build theories that are helpful when we face crisis. But then we need to ask, what if there are no crises in the future? Then it's kind of futile to develop those theories. If our best theories will never face a crisis, then it's a waste of resources to develop those novel approaches, because we could spend all our resources to put our best theory forward and go further or go faster into the future. And we have to notice that the future with crisis is only one possible future of science. It is a very credible possible future. It is very plausible, but it is still only one possible future of science. And we should still we would like still to understand what other possibilities there are to put the criterion based on crisis into perspective. So we would like to have a rich picture of different kinds of futures of science, whether there are crises, whether there are continuities, and so on, and then discuss different criteria of perseverance in terms of these futures. And this is directly related to the question 2 in the bottom of this slide. What could be the place of error in changing context of science? So, and in the paper I analyze this criteria against the Kuhnian taxonomy that I introduced earlier, and I use it as an example of a theory that might give us some ideas about how to understand perseverance, and I also criticize it about certain things. But here are the two applications. Both are based on the idea that some philosophical debates and discussions can be clarified, and we can make some progressions in those issues once we understand that we need to discuss the future, and in order to discuss the future we have to discuss scenarios of the possible futures of science. And my argument is that there, or I assume that there will be much more this kind of debates that could find it beneficial to discuss scenarios, or that could be discussed in terms of scenarios of the future of science. So I have reached my conclusion. It is twofold. First, I have argued that scenarios of possible futures can be formulated using philosophical theories to create rich taxonomies that enhance understanding and challenge conventional thinking about the future of science. So philosophy has value in discussing the future of science, even if we are not interested in those futures because of their philosophical value. But philosophy of science has quite high practical utility if used in this way. And the other side of the coin is that engaging with future-oriented questions opens new perspectives on issues in philosophy of science and can improve understanding of science overall. And theoretical plurality, which exists in philosophy of science, is a virtue because it enables exhaustive and challenging taxonomies. So here we discuss futures, even if we are not interested in the future as such. We are interested in philosophy, but we use future-oriented considerations to discuss philosophical issues. So both are based on the same basic idea about possible futures and creating scenarios, but these are two different angles to this same issue. Here are the references. I think I'm approximately on time, and I thank you all for listening to this.